Hello everyone. In this video we will discuss about characteristic equation and characteristic roots. Also it is called what here? Eigen values. See, let A be a square matrix of order 2 cross 2. For your syllabus only 2 cross 2 matrix is given. Lambda be a constant term and I is the identity matrix of same order. Same order means 2 cross 2. Then matrix of A minus lambda I, this is called what here? Characteristic matrix. So this is what we call it as what here? Characteristic matrix. Means when you subtract A minus lambda I value, when you subtract A minus lambda, A be a square matrix of order 2 cross 2, lambda be a constant term, and I is the identity matrix of order 2 cross 2. If you subtract this inside value, then we get one matrix. That matrix is called what here? Characteristic matrix. Now after removing this matrix form, if we add the determinant form here, then after solving determinant of A minus lambda I, we get one expression is called characteristic polynomials. So after subtracting in a determinant form, we get one expression. That expression is called what here? Characteristic polynomials. So polynomials means what? More than 3 terms is called what here? Polynomial. More than 3 terms. So after removing the matrix form, if we add a determinant form, after adding the determinant form, if you simplify A minus lambda I in determinant form, we get one expression. That expression is called what here? Characteristic polynomials. Suppose if we take determinant of A minus lambda I equals to 0, if we take this, so this is called what here? Characteristic equation. So determinant of A minus lambda I equals to 0. So this is what we call it as what here? Characteristic equation. If our matrix is of order 2 cross 2, then after simplification here we get a quadratic equation. So after simplification of determinant of A minus lambda I is equals to 0, we get what here? Quadratic equation. You know quadratic equation is of the form what? Ax square plus bx plus c is equals to 0. So after getting the quadratic equation, that quadratic equation only is called what here? Characteristic equation. So after getting this characteristic equation, next to simplify means to get characteristic roots or eigenvalues, what we are going to do? We are going to apply the factorization method. We are going to apply factorization method to find the roots. Suppose if a factorization method is not possible, then we are going to solve by formula method. Then we are going to solve by formula method, that is minus b plus or minus square root of b square minus 4ac divided by 2a. Now we will solve examples. In that examples you will get to know how to find out the characteristic equation, and using this characteristic equation how to find out the characteristic roots, that is eigenvalues. So example question: if A is equals to 1 2 2 1, then find characteristic equation and its roots. Otherwise how they will ask? Then find characteristic equation and find the eigenvalues. So both are same. So solution. So you know, to find out the characteristic equation, which formula you are going to use? Determinant of A minus lambda I is equals to what here? 0. we are going to use the formula determinant of what? A minus lambda I is equals to 0. But this inside value we don't know, correct? So this inside value we don't know, that is A minus lambda I. So first we are going to find out A minus lambda I value. So first here A minus lambda I is equals to, first A is the given matrix. What is the given matrix here? 1 2 2 1. Note down. So here 1 2 2 1. Next minus is there, so right here minus, then constant, that is lambda, so keep it as it is. I means identity matrix, that is 1 0 0 1. Identity matrix, that is 1 0 0 1. So which is equals to, first matrix keep it as it is 1 2 2 1 minus, first multiply this lambda with all 4 elements. Lambda into 1 is lambda, lambda into 0 is 0, lambda into 0 is 0, lambda into 1 is how much here? Lambda. So next, which is equals to, now subtract these two matrix. So first 1 minus lambda, first element with first element, 1 minus lambda, 2 minus 0, 2 minus 0, next 2 minus 0, again same 2 minus 0, and last 1 minus lambda, 1 minus lambda. So which is equals to, therefore A minus lambda I value is matrix of 1 minus lambda, 2 minus 0 means 2, 2 minus 0 means 2, 1 minus lambda. So this is the value of what here? A minus lambda I. So next, this value here we need to substitute now. Therefore, so what is that? For determinant of A minus lambda I is equals to 0. Now keep that determinant symbol as it is. Determinant symbol as it is. So next, A minus lambda I value is what? 1 minus lambda, next 2, next 2, next 1 minus lambda is equals to what here? 0. Getting? Determinant symbol, keep it as it is, substitute A minus lambda I value, that is 1 minus lambda, 2, 2 and 1 minus of what here? Lambda. So here now we need to apply second order determinant rule. You know second order determinant rule is what? Cross multiplication, middle always negative sign. See, while doing the cross multiplication, directly don't do the multiplication, because in the first element there are 2 terms, last element also there are 2 terms, correct? Therefore keep this value as it is. See, in bracket only you keep it, in bracket 1 minus lambda into 1 minus lambda. Okay, middle always which sign will come here? Minus. Next, these two you multiply, 2 into 2 goes to how much here? 4, which is equals to 0, which is equals to 0. Now simplify this, multiply 1 into 1 is 1, correct? 1 into 1 is 1. Next 1 into lambda is 1 lambda, plus into minus is minus, 1 into lambda is 1 lambda. Next these two, minus into plus is minus, lambda into 1 is 1 times of lambda. Next these two, minus into minus is what? Plus, lambda into lambda goes to what here? Lambda square. Minus 4, keep it as it is, equals to 0. So next, simplify this. See, in this entire equation here only one lambda square is there. That lambda square I am going to write it first, lambda square. Again here minus 1 times of lambda, minus 1 times of lambda. You know minus 1 is how much? Minus 2 times of what here? Lambda. Next here 1 minus 4. You know 1 minus 4 is how much here? Minus 3 is equals to what here? 0. So see, after simplification here one equation is got. This equation is nothing but what here? Characteristic equation. So this is what? This is characteristic equation. You have to write here, this is what? Characteristic equation. So after simplification, whatever the equation you will get, that equation is nothing but what here? Characteristic equation. So once we get this characteristic equation, next step of which value we need to find out? The roots. See, one thing you observe, see, after simplification we get the characteristic equation. See, always you will get characteristic equation is of the form ax square plus bx plus c is equals to what here? 0. So for this quadratic equation, if we apply the factorization method, then only we will get the roots. Therefore next step what we are going to do? We are going to apply the factorization method. Therefore lambda square minus 2 lambda minus 3 is equals to 0. So here lambda square coefficient is what here? 1. So multiply 1 into minus 3. 1 into minus 3 is how much here? Here side you know not, minus 3. 1 into minus 3 is minus 3. Next step what to do? So you have to split this minus 3 such a way that if you multiply these two values, you should get minus 3. You have next, if you add or if you subtract these two values, middle number you should get. You should get what here? The middle number. Therefore the values what here? Minus 3 and 1. Correct? Minus 3 and 1, because you know minus 3 into 1 is minus 3 and minus 3 plus 1 is how much here? Minus 2. See, after multiplication of these two values you are getting minus 3. After adding or after subtracting, here you are subtracting the values, what you are getting? You are getting the middle number. Next step what to do? This middle value you have to replace by minus 3 and plus 1. Therefore lambda square minus 3 lambda plus next one is 1 times of lambda minus 3 is equals to 0. Next, so see, in this first two terms, which term is common? Lambda is common, so take that lambda outside. So if you take the lambda outside, what is the remaining value here? Lambda minus 3. Lambda minus 3. Next, same lambda minus 3 here also we should get. Therefore what to do? Remaining two values in this two we are going to take plus 1 outside. Plus 1 outside. If I take plus 1 outside, what is the remaining value here? Lambda minus 3 is equals to 0. So next, see, so this is the first term, this is the second term. In these two terms, which term is common here? Lambda minus 3 is what here? Common. So I'm going to take lambda minus 3 outside. So if I take lambda minus 3 outside, what is the remaining value here? Lambda plus 1 is equals to what here? 0. Lambda plus 1 equals to 0. Next, to get the roots, we are going to equate. So lambda minus 3 equals to what here? 0. So first one is lambda minus 3 equals to 0, or next value is what? Lambda plus 1 is equals to what here? 0. Therefore lambda is equals to minus 3. If you shift to right hand side, minus 3 becomes what? Plus 3. And lambda is equals to plus 1. If you shift the right hand side, plus 1 becomes what here? Minus 1. Therefore you have to write what here? Lambda is equals to 3 and minus 1 are what? The roots. So these two are roots, are also called eigenvalues, and this one is what we call it as what? Characteristic equation. This one is characteristic equation. So this is how we need to find out the characteristic equation and its roots. So first what to do? First write down the formula, that is determinant of a minus lambda I is equals to 0. So next inside value we don't know. First we need to find out the inside value, that is a minus lambda I. So take a minus lambda I is equals to, a is the given matrix minus lambda into I is the identity matrix. Next multiply with lambda, then subtract, you will get 1 minus lambda to 2 and 1 minus lambda. So this value substitute here. So determinant of a minus lambda is equals to 0. So next determinant symbol, keep it as it is. Next substitute that value equals to 0. Next apply here second order determinant rule, that is cross multiplication with negative sign. So once we apply second order determinant rule, we get one equation. So that equation only is called what here? Characteristic equation. Once we get the characteristic equation, always characteristic equation comes in the form of what? Ax square plus bx plus c is equals to 0. So to find out the roots for this equation, we are going to apply the factorization method. So here is the factorization method. Once you apply the factorization method, at the end you are getting the two values. These two values are called what here? Roots of this characteristic equation. See, sometimes in examination you can skip this entire step. You can skip this entire step. See how to skip that value. Or see, first note down determinant of a minus lambda I is equals to what here? 0. First note down determinant of a minus lambda I is equals to 0. Next what to do? Determinant symbol, keep it as it is. Determinant symbol, keep it as it is, equals to 0. See, for this given matrix, see, these two are the principal diagonal elements, correct? So what to do? To skip this entire terms, so entire steps, to skip this entire step, what to do? For this diagonal matrix, you need to subtract lambda. See, 1 I am going to keep it as it is. I am going to subtract lambda, and this 1 I am going to keep it as it is. Again I am going to subtract lambda. Means for principal diagonal elements subtract lambda, and remaining two elements keep it as it is. Remaining two elements what here? Keep it as it is. So directly you will get this step. Directly what here? You will get this step. Easily you can skip these many steps. So what to do? First write down determinant of a minus lambda is equals to 0. Next determinant symbol, keep it as it is. Afterwards what to do? Only for principal diagonal elements, 1 and 1 is called what here? Left top to right bottom elements are called principal diagonal elements. For this principal diagonal elements subtract lambda, and remaining two elements keep it as it is. 2 and 2 keep it as it is. So directly you will get this value. So once you get this value, then apply the determinant rule, second order determinant rule, solve the problem. Next question. If a is equals to 3 minus 1, 0 minus 2, find characteristic equation and its roots. See, solution. So first write down the formula. So let determinant of a minus lambda I is equals to 0. So directly you do the steps. Next what I said, determinant symbol, keep it as it is, equals to 0. So these two are called what here? Principal diagonal elements. For principal diagonal element subtract lambda. 3 is there, subtract lambda. Minus 2 is there, subtract lambda. Then remaining two terms keep it as it is. Two values keep it as it is, 0 minus 1. So next apply second order determinant rule. See again here first term and last term contains two terms. So first element and last element contains two terms. So keep it as it is. So in bracket 3 minus lambda into bracket minus 2 minus lambda. Keep it as it is. Middle negative sign. Next plus into minus is what? Minus. 0 into 1 is how much here? 0 is equals to 0. Next solve this. Open the bracket 3. See first plus into minus is minus. 3 into 2 is 6. Plus into minus is minus. 3 into lambda is 3 lambda. Next minus into minus is plus. Lambda into 2 is 2 lambda. Minus into minus is plus. Lambda into lambda is lambda square. Next minus into minus plus 0 is equals to 0. So next in this entire equation only one lambda square is there. Keep that lambda square as it is. Here minus 3 lambda plus 2 lambda. Minus 3 plus 2 is minus 1 times of lambda. And here only one constant term is there, that is minus 6 is equals to 0. So this is what? So this is characteristic equation. Characteristic equation. Next what to do? For this characteristic equation we are going to apply factorization method. So here lambda square beside nothing means 1 is there. 1 into minus 6 is minus 6. So next split up. So here minus 3 and 2 I am going to take, because minus 3 into 2 is minus 6. Minus 3 plus 2 is how much here? Minus 1. See, after multiplication you are getting the minus 6. After doing the subtraction you are getting the middle number, that is minus 1. So next what to do? This middle number you have to replace by minus 3 and plus 2. Therefore lambda square minus this 3 lambda, next plus 2 lambda, next minus 6 is equals to 0. Next again same, in between first two terms which term is common? Lambda is common, take it outside. So if I take lambda outside, here remaining value will be lambda and here remaining value will be minus 3. Next same lambda minus 3 here also we need to get. So in these two terms we are going to take plus 2 outside. If I take plus 2 outside, what is the remaining value? Lambda minus 3 is equals to 0. Next again here also lambda minus 3 is there. In the second term also lambda minus 3 is there. So take lambda minus 3 outside. So if I take lambda minus 3 outside, what is the remaining value? Lambda plus 2 is equals to 0. Now compare with 0. Therefore lambda minus 3 equals to 0, and one more value is lambda plus 2 equals to 0. Therefore lambda is equals to minus 3. If you shift that side it will become plus 3, and lambda is equals to plus 2. If you send that side, plus 2 becomes what here? Minus 2. Therefore below you write lambda is equals to 3 comma minus 2 are roots. So these two are what here? Roots. Next question. If A is equals to 3, 5, 2, 4, then find characteristic equation and its root. Solution. So first again same, let write the formula. Determinant of A minus lambda I is equals to 0. So next what to do? Determinant symbol, keep it as it is. For these two principal diagonal element, subtract lambda. 3 minus lambda, 4 minus lambda. Remaining these two, keep it as it is. 2, 5 is equals to 0. Next apply second order determinant rule. So in the first element two terms are there, last element also again two terms, so keep it as it is first. So 3 minus lambda into 4 minus lambda. Middle negative sign. 2 into 5, 10 is equals to 0. Open the bracket first. 3 into 4 is plus into plus is plus, 3 into 4, 12. 3 plus into minus is minus, 3 into lambda is 3 lambda. Next, minus into plus is minus, 4 into lambda is 4 lambda. Minus into minus is plus, lambda into lambda goes to lambda square. Next, minus 10, keep it as it is, equals to 0. Therefore, in this entire equation, only one lambda square is there, that I am going to keep it first. So, lambda square minus 3 lambda minus 4 lambda is minus 7 times of what here, lambda, and 12 minus 10 is how much here, plus 2 is equals to 0. So this is what? Characteristic equation. So this is characteristic equation. So next, for this characteristic equation, we are going to apply the factorization method. See, but in this case, here it is not possible to apply the factorization method, because here 1 into 2 is what? 2 is there. So you cannot split the values. Middle number you should get how much here? Minus 7. Therefore, factorization method is not possible. So if factorization method is not possible, then we are going to use formula method. So you know that formula, correct? Therefore, first what to do? Lambda square minus 7 lambda plus 2 is equals to 0. It is of the form ax square plus bx plus c is equals to 0. Correct? First, a value, nothing means always one value will be there. A is equals to how much here? 1. B is equals to, consider the negative sign also. B is equals to minus 7 and C is equals to how much here? 2. Correct? So here we are not taking the x, we are taking what here? Lambda. Therefore, lambda is equals to, you write. Lambda is equals to, write that formula. You know that formula, minus b plus or minus square root what? 2a. Correct? Therefore, now substitute a, b, c values, which is equals to this negative sign. I am going to keep it as it is. B. B is how much here? Minus 7. Next, square root. Again, b square. B is minus 7 square minus 4a. A is 1. C is 2. Divided by 2a. So 2 into a is how much here? 1. So which is equals to, minus into minus is plus 7. So here I forgot to write plus or minus. So plus or minus into square root of, see, power is even number, so minus becomes plus. 7 square is how much here? 49. 49 minus 4 into 2 is how much here? 8. Divided by 2 into 1 is 2. Therefore, lambda is equals to 7 plus or minus square root of 49 minus 8 is 41 divided by how much here? 2. Therefore, two values are here, correct? Therefore, lambda is equals to 7 plus root 41 divided by how much here? 2. And one more is what? Lambda is equals to 7 minus root 41 divided by 2 are roots. Are the roots. So these two are the roots. So this is how we need to find out the roots when factorization method is not possible. See, same formula if you can use for previous example also. Same formula you can use here. Take it as a is equals to 1, b is equals to minus 1, c is equals to minus 6. Apply that formula, you will get the answer 3 and minus 2 only. Okay.